Good afternoon, students. Welcome to ETS. It's Dr. Jean Fourie here, and today we are speaking about the next unit in this module on education and teaching studies. The next unit is Unit 9. The unit has been opened on Moodle, so you can access the reading material. There's a couple of videos there, and there's some content to read. I'm going to go through very briefly what this content is about, and I am going to be looking at the assignment question, which is due on this content. To remind everybody that each of the units in this course has a particular question that you need to answer, and then upload those answers to the relevant assignment when it is open. So for this unit, we are dealing with forgetting and remembering. And this question will be the first question of the next assignment, AT3. The next assignment will be due on the 2nd of June, and it consists of 3 questions. And I will discuss that assignment again later in the lecture. So let's get right into the content for today, and we are continuing our theme on the science of learning, and we are continuing to speak about how human beings learn, what we have learned from research, what researchers know about how the brain works and how human beings learn. And we have been discussing the idea of the information processing model and the science of learning. And we are looking at components of this in each of our lectures. So here is the question that you need to look at for this particular week. And it reads as follows. You need to explain Ebbinghaus, that is a theorist who we're going to talk about. Explain Ebbinghaus's forgetting curve. We're going to speak about the forgetting curve, which shows how forgetting can be minimized and remembering can be enhanced. So that you're going to do as like a first little mini part of this question. And then you're going to explain one strategy that can be used in your classroom. In the lecture, I'm going to give you 6 strategies, and you are going to choose one of those 6 that you will do for this little mini essay that you're writing. So of the 6, you choose one, and you can choose any one that appeals to you. You will explain how that strategy works, how it can improve learners' ability to remember information, to retrieve and recall the content of lessons. And you will use that this one strategy can be used by teachers so that learners move from material that is foreign or unknown to a position where they have mastery over the subject content. And in your explanation, you will give clear examples from the subject area that you teach, and in order to explain this learning strategy that you can use in your classroom to facilitate mastery of content. So that gives you an idea of what you need to do, and we're going to be delving into the content of where this idea of forgetting and remembering comes from. So to refresh where we are sitting in this theme of the science of learning, we have been looking at this information processing model. And in this model, we have information that comes in, we have input from the environment around us. Information comes in, so on the left side of this diagram, and it goes into your senses. In fact, we engage with the world through our senses of hearing and sight and touch and taste. So our senses have very, very short memories called sensory memories. And at that stage of the information engaging with the sensory memory, a lot of information is forgotten. So this is the first stage where forgetting takes place. We cannot possibly remember in long-term memory every single sensory input that we get every single day from the world that we see and hear around us. So only a very short, small fraction of the information that we are receiving is transferred into our short-term memory. This is our consciousness, where we are aware of the information and we work with the information. We do something with it. We decide, sometimes consciously and sometimes unconsciously, to transfer and encode that input into our long-term memory, so into our memory that will be sitting in our environment, in our brain for a long time. This encoding, transferring takes place into long-term memory, and often we are not aware of what is happening in long-term memory until such time as information is retrieved, recalled, brought back from long-term memory into the short-term conscious awareness place where we work with this information. And information is forgotten at the short-term memory stage. So a lot of information that is sitting, that we're working with, we will forget, and only part of that, a small fraction, will be transferred into long-term memory. And we have this process of rehearsal, where we are retrieving information and rethinking it, looking at information to make long-term and short-term memories much more effective. So remember that this information that we are receiving is being filtered and distorted and interfered with at various different stages in this model. So here is a diagram explaining some of the filters and distortions that are taking place. And these all have an impact on how much we remember, how much gets forgotten, and what issues go into long-term memory. So in this diagram, we can see that there is input from perceptions in the external environment into our ears and eyes and nose. And the kinds of filters are all these other aspects over here. What information will be processed depends on the time that we receive the information, the kind of information we're receiving, the language in which it is, and the language which we speak. Are we understanding it, the words and the language that we are hearing? It is dependent on our emotional state. Our emotions have a very strong impact on how we learn and what information gets stored in long-term memory. Our underlying value systems, our beliefs, our attitudes will also have an impact on what information we allow to be received into the long-term filters and what information we will discard. And if it is, and a lot of this underlying beliefs are what will be referred to as underlying bias, and this idea that we tend to remember information that has much more resonance with our basic values, and information that does not resonate well with us, we will sometimes forget and ignore. So our physiology, our physiological state at the time when we are doing this particular learning, receiving information, will also have an impact on whether information is forgotten or filtered. Whether if we're hungry, or we are in a heightened state of anxiety, or we're feeling depressed, all those emotional, physiological, what is happening to our bodies, those feelings will also filter and distort and interfere with information. So please remember as teachers that what we teach, with the input that we think students are getting, is constantly being filtered, distorted by what is happening internally in the person's brain with regards to language, emotional states, values, physiology, past memories, past experiences. All these things are interfering with that process of putting information into long-term memory. Okay, so that's, I want to just elaborate a little bit more on this idea of the information processing model, just so that you get a very clear idea of all the places where inaccurate information, where there's inaccuracy that might occur, and where there is places where forgetting happens. So we've got, this is just another view of the information processing model. Information comes in through the senses into the sensory memory, and a lot of research has been done on how we receive information through our eyes and our ears and our senses, and we do know that a lot of input that we receive is inaccurate. People will see a thing happening, and 2 or 3 people will see the same incident, but they will report on it in very different ways. So we know that we are not all seeing the same thing in the same way. So inaccurate input. Then when we are moving information into our short-term memory, this is dependent on our ability to attend to and concentrate on the particular information that is coming in, how we recognize this information, what it means to us, and at that stage there can be loss as well. So there's decay. The scientific term for loss of information from sensory memory is decay. And not all the information going into our senses goes into our short-term memory. In the short-term memory, the term is called loss or displacement decay. So our short-term memories have got very small capacity. Last time I spoke about the 7 plus or minus 2 number of items, digits, facts that we can recall. So our short-term memory is constantly displacing the information that is in it in these small little chunks. And so that loss is called displacement decay. Information is encoded into long-term memory, and we do retrieval and constant backwards and forwards from long-term to short-term memory. And in the long-term memory as well, information will be lost as time progresses. And we all know of elderly people who forget things that they used to know because there is this natural decay that happens in the long-term memory. And so that interference cues that we use in order to remember things get forgotten as we are replacing that long-term memory by new memories and other things. And if we don't recall these things regularly, retrieve them into short-term memory, there is a constant loss happening there. So all of these are contributing to the idea that we are forgetting information on a regular basis, and the information that is being encoded into our long-term memories is often inaccurate and part of information is encoded and not everything. So it's useful for us as teachers to be aware of these complicated processes happening in the brains of the children that we are teaching, so that we can come up with some ways to mitigate and to ensure that much more information is enhanced and remembered in long term and less forgetting takes place. Okay, so I want to speak now about particularly this theorist, Hermann Ebbinghaus. He did his research in the 1900s, and he gave people, children, people of different ages, he gave them information to learn and recall, and then he studied how much information was recalled and remembered. So I'm going to give you the basis of his theory, and then we're going to go and have a look at some strategies that can be used in order to increase the amount of information that we remember. So if you have a look at this graph over here, this is a very simplified version of what is called the forgetting curve. And think about giving a group of people a list of topics, a list of information that they need to remember. Let's say, you know, the capital cities of the world, or a set of numbers that they must remember. And you give it to them at time 0. So on the x-axis is time, and this time is shown here in days. So at 0 time, the learning process takes place. At 0 time, somebody is given this information, and immediately after the lecture on the y-axis, they will be at more or less 100%. They will have a pretty good recall of most of that information. But the information decays and is forgotten very quickly. So if we look at this red line, this is how quickly information gets lost, decayed, forgotten. By the next day, in 24 hours, half the information that was presented will be forgotten. So if you give the person a test in day 1, they will only remember 50% of the information. If there is no opportunity to recall that information, day 2, they will have forgotten half of that again. In day 3, you ask them to recall that information. They've forgotten half of what they gave you in day 2, and day 4, even less, up to sort of day 6, a week later. And at that time, the person will have remembered just a small little fraction of what they will remember what the content was about, maybe, but all the detail that was given at time 0 will have been forgotten. So the Herman Ebbinghaus then said, how can we improve this remembering so that people will not forget so much information? And he came up with this general idea that after 24 hours, so we go back to time 0, we give the person the information at time 0. 1 day later, we make the person reread or re-listen or somehow, re-look at all this information again. So we take them back to the 0, back to 100%. If we then do not present the information again, and we test them and see what happened at time 2, they have not lost as much as they did the first time round. So the second time, they'll only have forgotten by day 2, they've forgotten about 25%. We test them in day 3, and they will have forgotten some of it, but it is much, they remember much more than they would have if they did not have the second input. And if we have a look by day 6, the amount of recall is much higher. So let's say they're remembering about 10% of the information. Now, if we do this experiment again, we start at day 0, we give the information at day 0. 24 hours later, in day 1, we present all the information again. We make them reread everything, re-listen to the video, and they back up at 100%. Day 2, we now present the information for the 3rd time. So the information is presented on day time 2, but it's the 3rd time they've looked at the information. And we now test to see how much have they forgotten. And we see that the curve is much higher. The person remembers much more. So everything at the bottom of this graph is remembering information. And by the time we get to day 6, they've remembered, let's say, 50% of the information is able to be recalled quite easily without too much decay happening, or certainly not as much decay as happened if there was only one viewing of the information. Okay, so now we run the experiment again. We give the person information at time 0. Day 1, we make them re-look at the information, reread it. That's the second time. We then, on day 2, we give the information again. And day 3, we give the information again. So we have this 3 days where the information has been presented again. So now we have been exposed on day 0. We've done a rehearsal on day 1. We've done a rehearsal on day 2. We do a rehearsal on day 3. And if we now test the person on day 4 and see have they, how much have they remembered, they just forget a small little bit. And day 5, they forget a small little bit. Day 6, they forget a small little bit. And that tends to be quite constant. So from going forward, that information now is more or less constantly present in long-term memory and can be recalled quite easily. And the person is only forgetting a very small percentage of the information that they need to remember. So this graph is called the forgetting curve, and these experiments set a very a precedent for what is very, very useful strategies for us as teachers to be able to figure out how we should be teaching and how we should be studying whatever we need to study. So if you think about this, there should be time where, as a teacher, you are presenting information, brand new information to people. And then the next day, the learners should have a chance to review that information again. You don't need to test them or do any, to see whether they know it, because this was an experiment. But for us as teachers, we need to, on the second day after the day, 24 hours after we've presented information, the next day, that information should be brought back to viewing. We should look at that information again. All the notes, read it, view it, re-look at the information. Day 2, we should look at the information again. And day 3, we should look at it again. And then that information will be we stand the best chance of having most of that content stored in long-term memory. Okay, so I want to just go into a little bit more detail now that you understand the basic principles behind the forgetting and remembering curve. And this gives the same basic principle concepts, but now there's all sorts of percentages. We've still got time on the x-axis, day time 0, but now this particular this particular graph shows us time in hours and days. This is a more refined version of the forgetting curve. And in this particular experiment that was run, we asked, or Ebbinghaus did a first repetition of the information in the first hour. So quite soon after the information had been presented. So information was presented in time 0. Within an hour or so after that information was looked at the first time, the student was asked to do a first repetition, to look at it again, to read it again. So that's the first repetition. And decay occurs, but the difference in decay is slightly less. The person is then asked to do a second repetition of the information in day 1. So we go back to presenting all of the information again. second repetition and a day later. And you can see that the decay that happens is much less, and long-term decay will only be about 50% of the information gets lost. However, if we then do a third repetition 3 days later, third repetition on day 3, the information decays to about a 70% level. And the recommendation is that on day 6, one should do, or a week later, one should do a fourth repetition, takes it up to the top, and then the decay will be about a 10% loss and 90% recall. So we are, as teachers, we should be thinking about how are we setting up our learning environments at schools in order to ensure that there is time for all these repetitions of information to take place. And are we teaching children to do this these active repeats and active reviews of the content so that what we are teaching stays in long-term memory as long as possible. Okay, so it's present information the first time. You should do a repetition as close to, once you've viewed the information, first repetition as close as possible, second repetition the next day, third repetition 3 days later, and fourth repetition about a week later. So that principle of repeating and repeatedly looking at content allows for content to get into long-term memory more effectively than if you just look at the information one time and think that you kind of have it. And also, because of these times that require, a day, or 2 days, a week, it's not a good practice for people to be cramming just before an exam and think that they're going to recall enough information. So if you're going to be setting up a study timetable before some test or an exam, that you need to think about where are the times that I'm going to be repeating all of this, so that I want 4 repetitions for the content before I need to recall it for an exam purpose. So we're going to go on now. So that is an explanation of Ebbinghouse's remembering and forgetting curve. And I want to go on and speak about some strategies that have developed since this research was done that are allowing us to really capitalize on this idea of remembering and forgetting. Okay. So this is a method called Cornell's notes. And as you can see, this very clearly says you learn the information the first time. In this particular one, you review information on day 1. And Cornell's just saying that to do a review on the first day, you're looking at keywords, questions about content that you didn't really understand. You're trying to really make sure that you understood the information that was presented the first time round. By day 3, in his particular time frame model here, in day 3, you're making a summary of the information. so that you have an executive or an abstract summary of, or a mind map, a concept map of the content. And then a week later, you do a complete independent review of your mind maps or your concept maps and recall all that information. Okay, so there are lots of different, slightly different variations on this forgetting and remembering curve, but you can see that the principle of retrieval and re-looking at the input on a regular basis is the same. Okay, I'm just going to skip some of these slides. I'll get back to them later. I want to go into the six cognitive strategies that and give you their names that emanate from all this research on remembering and forgetting. And remember, for your assignment, you're going to choose one of these strategies. So the first one is called spaced practice. And another name for it is distributed repetition. So you might, if you do a Google search, you will put in these keywords, spaced practice or distributed repetition. And basically what this is, that you are repeating the same information, but you are spacing it out over time. And we know, if you have understood the principles of Ebbinghaus's forgetting and remembering curve, you can see exactly where these ideas of spaced practice and distributed repetition come from. We are spacing out our practice. We are repeating the information, but at very strategic times. Immediately after you've received the content, you're doing it a day later, 3 days later, a week later. And so research on spaced practice and distributed repetition, a lot of research has been done on this, and it emanates directly from Ebbinghaus's forgetting and remembering curve. And there is readings on this in the unit for you to go and have a look at. The second strategy is called interleaving, or interweaving sometimes. And this is very useful for teachers where we are teaching lots of different topics. And how do we, we can't teach one topic and then wait for a whole week later and then teach another topic. So on Mondays, you're teaching one topic. On Tuesday, you're teaching another topic. And Wednesday, you teach topic 3. But the repetition of these topics needs to happen. The recall, the repetitions of topics 1, 2, and 3 needs to be carefully planned. And this idea of interweaving or interleafing is where we are doing one topic, then the next topic, then the third topic, and then on day 4, you repeat all of the topics, and you're switching between the different topics so that you are recalling, you're doing spaced repetition for each of the topics, but you have many topics that you are kind of juggling over the days when you are doing studying and recalling of these topics. So you can read up on a little bit more on this strategy and its how it can be used effectively in classrooms. And strategy number 3 is called retrieval practice. you'll recognize the word retrieval from the information processing model, where we are retrieving content from long-term memory, bringing it into short-term memory, into our consciousness, into our foreground, so that we can do something with it, so that we can say it, speak it, write it, build it, make clay models, design something, teach your dog, teach your friend, all of these things where we are retrieving the information from long-term memory is practice that is making that information stronger when it gets re-encoded into the long-term memory. And we then have the time when we're retrieving to think about what is it that I don't know, what things do I have incomplete information about, and we are relearning what you couldn't recall. You're thinking, what are the things that I recalled that were inaccurate or that I forgot about, and you're checking to see, have you covered and being able to recall everything that you should be able to on that particular aspect. So you're relearning what you were unable to retrieve from long-term memory. And this retrieval practice helps to, it's also called rehearsal. It helps to ensure that the information in long-term memory is built much stronger, and the neural architecture in long-term memory is less inclined to decay because you have strengthened those neural pathways. Okay, and if we have a look at the fourth strategy, this is called elaboration. And in elaboration, we are using various different ways of presenting the information, thinking about the information. The more elaborate the neural architecture is that we build around a topic, the stronger the recall and retrieval of that topic will be. So we will ask people, why are we doing this particular thing? How does it have relevance? Give some details, explain it to somebody else, link the new knowledge to past knowledge. If you go back to the work of Jean Piaget, where we spoke about schema as the neural networking in the brain, a way that we build constructs and concepts of the world around us, works because we are linking the new things to past previous knowledge. And the aim of all this elaboration and using different modes of input, our eyes and our ears and our taste, using all of that is to build complex schemas, and we want to have a very good understanding of whichever the concept is that we are studying, so that we can retrieve aspects of it and think about it in more complex ways. And making visual representations, good summaries, mind maps, having good keywords, knowing how to take out, highlighting important aspects in a text, for instance, being able to really manipulate and work with the content if it's whatever subject it is. This idea of elaboration and using varied modes is a strategy that helps with recall and with long-term, putting information into long-term memory. Okay, then a fifth strategy for ensuring that we learn things effectively is this idea that we use concrete examples. And a lot of what we are teaching at school is abstract. We have principles. We are using terminology that is in the realm of imagination, even something like, gravity. We feel it all day, the idea of gravity, but we can't really see it. So we need to really have concrete examples of a lot of the concepts that we teach at school. So try to give real life objects where possible, something that the child can relate to, show pictures, have videos explaining it, and use concrete teaching aids. These are very useful for maths and science classrooms where we are using counters and manipulating real objects in order to teach particular concepts, doing experiments, and so on. So the idea of concrete examples feeds into the information processing model by tapping into our sense of touch and taste and smell and feel, so that we are using as many senses as possible, not only the sense of sight and hearing. So being able to really get other senses involved is very, very useful in assisting with this. Okay, and the last strategy, number 6, is called dual coding. And you will see that dual coding, a lot of these strategies interrelate to each other, and they, a lot of them are terms which can apply to other strategies. So there's a lot of interlapping. Dual coding is where we are combining different sensory inputs, and we know that the stronger the sensory input is, the better we will be filtering the information that goes into short-term and long-term memory. And so for dual coding, the word dual means two. And when we speak about coding, we're actually referring to encoding, where information is encoded from short-term memory into long-term memory. And here you would be consciously thinking about what are the different ways that information is going in to the learners. Are we using different language modalities? Are they talking themselves through this thing? Self-talk is a very useful strategy when you're doing all sorts of things. You're doing a maths calculation, you need to be speaking to yourself in your head. If I add this and subtract that or multiply this, you're constantly having this metacognitive dialogue, and that's also part of the sensory input. We're writing things, singing them, dancing, using pictures and words, and drawing things. We're using auditory, visual, motor, multimedia, as many different codes as we possibly can. I've made a note here about one little aspect of research that has been done on pictures, looking at actual either a video or a picture of a particular concept. And this is called the picture superiority effect. You all know that one can talk about something, but as soon as you see a picture or a video of it, that it suddenly comes to life and you have a much better understanding of that particular thing. So this is called the picture superiority effect, and this is just a little small part of this whole idea of dual coding and combining, having multiple ways, multimedia, that we are presenting information to learners, because all of that will ensure that there is much more engagement with the topic, and that the topic is being thought about and encoded as strongly as we can and as accurately as we can into long-term memory. Okay, so I'm going to just show you this. There's a quote by William Ward that says, "The mediocre teacher tells, the good teacher explains, and the superior teacher demonstrates, but a great teacher inspires our learners." So I hope that you're going to be thinking carefully. Oh, can you just turn your microphone off? I hope that you're going to be thinking carefully about how you present information and how you can use the forgetting and remembering curve in order for people to remember things. Okay, so I'm going to go back to the meeting and see if there are any questions in the chat. Let me just remind you that we are dealing with Unit 9. I will put the recording up in Unit 9's content. It relates to forgetting and remembering. And this is question 1 of your next assignment, which is assignment 3. That is due, assignment 3 is due on the 2nd of June. Assignment 3 is due on the 2nd of June. There are 3 questions for assignment 3. Question 1 relates to Unit 9. Question 2 relates to Unit 10. And question 3 relates to Unit 11. We will do Unit 11 next week on the 27th. And that assignment will then be due the week after that. Okay, so let me see if I can go back to the question just to remind you. So I'm just going to go back to the question right at the beginning. Okay, so the question for this unit is explain Ebbinghouse's forgetting curve, showing how forgetting can be minimized and remembering can be enhanced. And I think I gave you a detailed explanation of that. There's also some videos in the unit that you can have a look at, because it's good to get information from different sources, the same principles, but maybe explained in different ways, because then you really understand it. And then you're going to explain one strategy that can be used in your classroom to improve learners' ability to remember, retrieve, and recall the content of lessons. I gave you 6 possible strategies. You're welcome to use one of those, or if you find in your research, you find another strategy that relates to remembering and enhancing memory, then you can use that. This one strategy must be used by teachers so that learners move the material from what is foreign or unknown to a position where they have mastery of the subject content. So we are going from a time zero where the person does not know that information, it's foreign, it's unknown, to a time maybe a week later or a couple of weeks later where the person has mastery of that content. So they were able to remember most of it and do something with it. And you're going to give clear examples from the subject area that you teach to explain this learning strategy that you will use in your classroom to facilitate mastery of content. So this is the question that you are doing for assignment 3, and you should be working on that in the next couple of days. Okay. I'm going to stop sharing there, and I'm going to go back to the chat and see if there are any questions that require clarification. There's a student that says, can you please rename the strategies that we must choose under for our assessment? Okay, so can you just look at the video? They're in my video and they're in another video in the unit. Those 6 strategies, spaced repetition, dual coding, and so on, they are clearly labeled in the video. You choose one of those strategies that you're going to focus on and give clear examples. Okay. Komogelo, yes, for assignment 3, there will only be 3 questions. The last question weighs a little bit more. I have opened up the assignment 3 on Moodle, so you can go and have a look at the questions and the weighting of the questions. We are heading into the mid-year recess. So we are not going to have 4 questions for this assignment. And there are 3 questions that you will have to do for assignment 3. Okay, so thank you very much, everybody. I'm going to turn the recording off now, and I will put this recording up into Unit 9, the forgetting curve. Remember from the principles of this lecture that you should watch the lecture sometime this evening would be good, and then again in a day's time, so that you remember and you get maximum memory from the content that is presented. So thank you very much, everybody.
Thank you, Ma.